Hey everyone, can't be with you because of a unforeseen appointment, so sorry about that. I know tomorrow is supposed to be the quiz, and it is, but as I have offered, please continue sending questions my way through email as you have done throughout the weekend, and I'll get to them as fast as I can. Okay? We've got chapter 2.3, polynomial equations. So if you've been practicing for the quiz, today's going to be a pretty good day because it's everything that you've done, but in different scenarios. Like if you remember in grade 10 and grade 11, once you have learned how to factor something, there were different kinds of questions where your factoring skills came into play. Like for example, if you had some kind of x squared plus 2x plus 1, and you learn how to factor into two different binomials, great. But now, instead of just factoring, the question extended into, okay, I have 2x squared plus 2x plus 1 equals a 0, right? And so when you factor, when does that equal to a 0? And that's how the roots or the x-intercepts come into play. It's going to be the exact same thing with cubic or quartic or whatever. It is going to have something at the end equaling 0. And if it's not, you change it to 0 so that you solve for the x values that makes this statement true. So let's see if we can get that in gear. Please note, I am probably going to move a little faster than people are willing to draw or to write down. And so I'm going to request you reach out to the substitute to pause momentarily if possible. If it's taking a little too long, then I would say the link to this will be also posted on our Brightspace. That would be right here. I'll put a lesson recording right there for you. Okay, so you can watch that and copy whatever you need to on your own time. So if you think I'm going too fast, just put down your pencils and just listen. All right, here we go. Example 1, there are situations where it's way too hard to solve by hand. Okay, so you can use technology. Like for example, let me bring out Desmos. Right, we've got, right, and so you can say, hey, I'm going to still try, assuming this is x to the power of 3 plus 0x squared and then minus 4x plus 2. Maybe there are possible factors for this polynomial because the possibilities or the factors of the constant is very small. So let's try it. If I have positive 1 in there, cubed, plus 0, minus 4 times 1, plus 2, does that ever equal 0? No. How about negative 1? Negative 1 cubed, plus 0, plus a 4, plus 2. Does that equal 0? No. Let's try 2. 2 cubed, which is 8, plus 0, minus 8, plus 2. Does that equal a 0? No. How about negative 2 cubed? Negative 8, plus 8, plus 2. Does that ever equal 0? No. So there are no possible numbers that help factor this. Okay? So there it is. So sometimes you do need technology. Of course, on quizzes, I probably won't be giving you that. But anyways, cubed minus 4x plus 2. Okay, we've got y equals x to the power of 3 minus 4x plus 2, I believe. Okay, so the x-intercepts are something ridiculous. Negative 2.21, 0.54, 1.68. So for questions like this, yeah, the only way we can identify the solutions is using technology. Negative 2.21, 0.58, L4, and 1.68. What can we do? It is what it is. So don't worry about this. Obviously, this is not going to be on the quiz, but sometimes use tech to help you out. Okay? Other times, you might recognize this. Can I solve this right away? No. As we saw in the previous example, the only way we can help ourselves is making one side of the equal sign a 0. And then we factor whatever's left over. So let's do that now. I'm going to subtract both sides by x to the power of 3 minus x to the power of 3. So this becomes 1x cubed plus 2x squared plus 2x squared, which gives me negative 3x squared. plus 7 and plus 7 with an x. Plus 7 gives me negative 3. Here it is. So you could go ahead and look for numbers that are factors of negative 3. But looking at this, I actually identify a pattern. I notice a pattern of 3, degree of 3, 2, 1, and 0. I also see a pattern of positive 1 coefficient, negative 3, positive 1 coefficient, negative 3. Because of all the practice I've done with cubic and whatnot, I recognize this quadnomial, this polynomial. I'm going to group factor this. It's going to be x to the power of 3 minus 3x squared plus a positive x minus 3. Okay, so the first two terms and the last two terms are separated with a addition. Common factor, x squared comes out, that's x minus 3. There's nothing else to factor, so I'm just going to leave it as a 1, that's x minus 3. And I know I'm on the right track because the factors or the binomials I get on both terms are identical, or they're common. And so I can say that. So what x values solve this equation? That means it solves when x minus 3 equals 0, and it solves when x squared plus 1 equals 0. Okay? So we've got x equals a 3, or x equals a negative 1, and clearly you can't square root a negative 1, so it does not exist. The only x-intercept of this polynomial, or this, sorry, I'm going to say x-intercept, the only answer that makes left side, what is going on? The only answer that makes the left side equal the right side is when x equals 3. There's only one solution. Okay? Another way you could say it is, the only time this polynomial intersects that polynomial is at x equals 3. You can say it like that as well. Okay? So, group factoring. Must you do group factoring? No. As I said, you can find the factors of negative 3 and use integral 0 theorem and factor this on your own, and you will get this as your answer. All right? That's example 2. I wonder if right now, if there requires a short break and pause before moving on. Okay. But assuming you've done that, I am going to continue. Sometimes, example 3, it's not particularly factorable when we get to the quadratic. And so you have to use quadratic formula. This is an expectation that I already think that you should have. If not, I highly recommend you review. So here it is. This time, one side of the equal sign is already a 0. I'm trying to make this true. So I see every single term is going to have an x. I'm actually going to factor that out. I also notice the coefficients are multiples of 4. I'm going to do that all at the same time. Factoring out a negative 4x, I have x to the power of 3, 6x squared, 9x, 2. And then from there, I'm going to focus on this part, factoring this part out. So I know negative 4x is there, but I want to use integral 0 theorem to see if I could factor that. Okay, so bringing that aside, let's do a side calculation. What numbers can multiply to 2? Plus minus 1 with plus minus 2. So let's test it. If I plug in, let's call this little section, the highlighted section, let's pretend that's the function f of x. If I plug in a 1, that becomes 1 plus 6 plus 9 plus 2. That's definitely not a 0. If I plug in a negative 1, this is negative 1 plus 6, negative 9 plus 2. Negative 10, that's not a 0. If I plug in a 2, this becomes, there's no way that's a 0. Let's plug in a negative 2. Negative 8, 4, 2, 4 plus 6, 24. Negative 2, negative 18. plus 2. This looks sort of promising. Negative 26, positive 26. Right on. There it is. Once I find it by muscle memory, I'm going to go straight to division. 1, 6, 9, 2 for the function. My root is negative 2. Drop down, negative 2. Add, multiply, 0. Great. That means, let's bring that over here. If my divisor is x plus 2, because the root is negative 2, what I'm left with is x squared plus 4x plus 1. And I'm hoping you realize right away, two numbers that multiply to 1 is 1 and 1, but it can't add to 4. It could be negative 1, negative 1. It won't add to 4. So I'm stuck. This portion, I can't factor. Not factorable. So what do? We need to ensure, though, that there are no other answers. So I'm going to employ the discriminant of the quad formula to ensure there are no other answers. So let's try it. The discriminant, remember, the square root, b squared minus 4ac. I'm checking to see if this is solvable, if there's a negative, a positive, or a 0 in there, right? So b squared is 4 squared, that's 16, minus 4 times a times c. Ooh, unlucky for you, it's a positive number. It is solvable. So not only is there an x or a root of 0 and a root of negative 2, there's going to be two roots. X can also equal negative b plus minus the discriminant divided by 2a. And I am going to simplify that. This is going to be negative 4 divided by 2 plus minus root 12 divided by 2 is the same as saying root 12 divided by root 4. That's going to be 3. You might be wondering how this comes about. Please note that negative 4 plus minus root 2 divided by 2 is the same as negative 4 divided by 2 plus minus root 12 divided by 2. And that is the same as negative 2 plus minus root 12 divided by root 4, because 2 equals root 4. And then I can say negative 2 plus minus. If you have the same square root, it's not cube root, it's not fourth root, they're both square roots. It's sort of like having the same exponent. You can apply the base as so. There. A lot of students get really tripped up on this because they don't have much experience, or much practice rather, with roots. So I understand if this part is a little confusing. You won't have to worry about this for the quiz, of course, but this is the proper form. This would be PF approved. If you gave me decimals, that wouldn't be the exact answer, and you would get slightly docked on the communication portion of your mark. So if you're wondering how this works, of course I'll explain more in our exponent section, but that's far from where we are right now. So you may want to go back and review this. If not, come and ask me. Maybe I'll make a little video by request if there are many people asking for it, explaining why this is the way it is. All right. In any case, the x-intercepts are 0. Therefore, not x-intercept. I keep saying that. Therefore, the solutions or the roots that make this statement, oh my gosh, I'm kind of dying here. The answers, the values of x that makes this equation true, where this giant thing equals a 0, is if x is equal to 0, x is equal to negative 2, or 0, or negative 2 plus minus root 3. Okay. And that's it. So that's a lot. Okay. It's not so bad if you understand what's happening here, but if you're still sort of questioning how I found positive, negative 1 and 2, how I did this, why I did synthetic when I did synthetic, how did I bring it back, and then suddenly start using quadratic formula, you're going to have to go back to this video and try to slow it down a bit. Okay? My final question to you is a bit of an application. I don't consider this thinking, but it will use your knowledge of setting an equation to 0 and using remainder theorem, factor theorem to find the answers or solving an equation. Okay, check this out. It's a terribly, terribly, terrible one. Here we go. Solving for a root, not an x-intercept. The height in meters of a certain roller coaster car above the ground can be modeled by the equation height is equal to some function of time. Time is between 0 to 30 seconds. T is in time in seconds. For how long is the car above a height of 24? So basically I'm saying, when is this equation bigger than 24? Okay, so we haven't done inequalities just yet. So what I'm going to do is I'm going to quickly sketch out this graph because I know the leading coefficient and I know the degree. I'm going to, what do you call it? Quickly, draw a dotted line of 24 meters. And I'm going to actually check when is it equal to 24 to solve this question. Watch this. Okay. First off, I see that we have ourselves a very, very terrible leading coefficient. So first, I'm going to check when is this roller coaster equal to 24 meters above ground. Okay, I am going to first get rid of some of these decimals. I'm going to divide everything in this equation by negative 0.001. So 24 divided by negative 0.001 gives you 24,000. Yes, this becomes positive t to the power of 3. This becomes negative 59t, oh shoot, power 4. Ooh. See, if I was here in person, you'd be able to tell me that I did something wrong, but in a video, I don't hear the complaints, obviously. Okay, that's power of 3. This is negative 1190 t to the power of 2. This would be, oh my gosh, I'm struggling here. That's a plus. That's a plus. And positive 9.4 becomes a negative 9400 t. And if you want to find the solutions or the roots of this equation, you need to set one side of the equal sign to 0. So the equation that I'm actually working with is all of this plus 24,000 on the other side. So here's Mr. Evil Mr. Kim. What are the possible factors or roots of this equation? You'll have to look at this. It could be plus minus 1, plus minus 2, plus minus 3, plus minus 4, so on and so forth, all the way up to plus minus 24,000. That's a little rude. So I'm going to cheat by looking at our answer key from the previous time that I've done it. If I can find it. And throw you a bone here. I'm going to say 5 is a factor, okay? So let's pretend you've done positive negative 1, positive negative 2, 3, 4, and you finally got to a 5 and it works. Let's test it. Let's pretend all the stuff on the right side of the equal sign is function, f of x, and plug in a 5. 5 times 5 times 5 times 5 is 625, minus, oh gosh, I need a calculator right next to me right now. Negative 59 times 125 is negative 700 that, plus 25 times 1190 is 29750, minus 9400 times 5, 47,000 plus 24,000. At this point, some of you might have stopped writing, and that's okay. I hope I'm doing them right, because it doesn't look like it's going to turn into a 0. Let's see. 625 minus 7375 plus 29750 minus 47000 plus 24000. Oh, it does. Just kidding, I tricked you. Okay, so therefore, x minus 5 is a factor. Yay. I am going to, by muscle memory, go straight into division with exponent -1, negative 59, 1190, negative 9400, and positive 24,000 with a 5 here. 1, multiply, 5, add, negative 54. Negative 54 times 5, negative 270. Add, that's negative 920. Multiply, negative 4600. I'm doing something wrong again, aren't I? 70, that's positive. Oh gosh. And then when you multiply, that's a positive. So 9400 minus, that would be a negative 4,800. And when you multiply, it is negative 24,000, which gives me a remainder of 0. Oh, okay. We've got f of x is equal, not f of x. So the original function is now x minus 5 times x to the power of 3 minus 54x 2 plus 920x minus 4800. I guess we'll have to keep going. Can I cheat? What other number can be a factor of this cubic function? It says 10 is another factor, so there it is. 10 to the power of 3 minus 54 times 10 to the power of 2 plus 920 times 10 minus 4800 is a 0. Therefore, x minus 10 is a factor. Right? Don't stress out about the big numbers. Like, if I gave you an equation like this, this is what you would do. And you probably have more manageable numbers, of course. So let's do it. Once again, by reflex, as soon as you find a factor, we're going straight into synthetic, and that is a 10, 1, 10, negative 44, 440, oof, this is testing, 480, 400, 4,800, and 0. Yay. Therefore, x minus 5, x minus 10, x squared minus 44x plus 480 will equal a 0. And I'm hoping that I can factor this in my head. Two numbers that multiply to 480, but gives you that. 48 times 10, no. 60 times 8, too big. 60, 50, 48. 48 times 10, that's too big too. Oh man, what am I doing here? 20 and 24. Yeah, I wouldn't have thought of that with my tired brain right now. Negative 20 and negative 24. By multiplying these two, I get positive 480. By adding these two, I get negative 44. There you go. So the roots are 5, 10, 20, and 24. Please be aware, what we found are not x-intercepts. Okay? I would be wrong, actually. These are technically x-intercepts, but they are not x-intercepts of our original question. They are x-intercepts of this thing that we made up. Right? This is nothing like what we have here. It's a very different equation. However, the reason why we took our original equation and turned it into this is because this is solvable while this is not yet solvable. We can't put a 24 here and figure this out. It's impossible. All of our techniques only work when one side of the equal sign equals 0. That's why we did what we did. And if we find the x-intercepts of this is same, it's the same as roots of that. Okay? Because this is equal to this, any answer for this is the same answer as above. So the answers or the roots that make this equation a 0 are the same roots that make this equation equal 24. And so what does that mean? For our made up equation, my x-intercepts would be 5, 10, 20, and 24. And being a quartic with a positive leading coefficient, it would be something like this. Oops, what am I doing? It would be something like this. Something like that. Okay? But look here. That is nothing like our original equation. Our original equation actually has a negative leading coefficient, which means the original function is something like I'm going to say something like that. And what are these dots that I drew at the timelines of 5? Uh-oh, I think I'm lagging. One sec. Yep, definitely lagging. Give me a sec. Don't send. Oh, heck no. Oh, man. Okay. Oh, life doesn't like me much. Okay, so being corrupt, let's go. That's fine. What I was trying to say, and again, you can go back to the video and try to pause where I was going. What I was trying to say is the modified equation that I had that was 5, 10, 20, and 24, with a positive leading coefficient, this is essentially what we found. We have 4 x-intercepts. But if we go use that and use those answers for our original equation, the special points of 5, 10, 20, and 24 are actually when the roller coaster reaches a height of 24 meters. Because remember, the made-up equation, we set one side to 0 and we factored. And the solutions for these 4 are the same numbers for when the original function equals 24 meters high. Okay? So that's a rough one. But even if it's difficult to process what the question is asking for, the mechanics, trying to figure out what the special number of 24, where that comes from, and then making one side equal to a 0 so that you can solve, that is something that carries over from grade 9, grade 10, and grade 11. So the homework that is assigned on the handout, would you go and check it out, review it, okay? And of course, still freshen up your skills for the quiz. Also, remember to, just as I wrote on the Brightspace announcement, make sure along with your chapter 1 remainder theorem, chapter 2 factor theorem, integral 0, rational 0 theorem, you also practice your cube sum and difference of cubes. Okay, the video was a little long and we had some technical difficulties, but I hope you got it. Remember, this link, video link, is on Brightspace, so you can watch it again at home if you have things you catch up on or you want to slow down on some things that I've said. Okay, best of luck. Send questions my way, keep them coming, and hopefully by tomorrow we'll have all the bases covered.